Welcome to the deep dive. Our mission here, well, it's pretty simple. Cut through all the noise and give you the essential knowledge you need straight from the best sources.
And today, we're diving into the age of artificial intelligence. We're using some great research from leading thinkers, new scientists.
Right. And the goal isn't just headlines about killer robots, is it?
No, not at all. If you only listen to the news, that's all you hear. Hype, promises. Our real mission today is to get under the hood, to understand this fundamental, almost philosophical shift that made modern AI possible.
Okay.
It's really the story of how we stopped trying to hard-code intelligence with rules.
Gave up on that approach.
Basically, yes. And instead embraced machines teaching themselves using just sheer overwhelming amounts of data. That pivot, that changed everything.
Okay, let's unpack that. Starting at the beginning. It feels like mechanical thought is a recent idea, but it's not, right?
Not at all. The idea that you could formalize arguments or process thought mechanically, that goes back centuries.
Way back.
You really have to start with Aristotle, the Greek philosopher. He formalized the syllogism.
Ah, yes. The classic all men are mortal example usually comes up.
Exactly. Or, more formally. Some G are B, all G are K, therefore some K are B. The structure itself guarantees a correct outcome.
Regardless of what G, B, or K actually mean.
Precisely. It showed that a mechanism, a structure, could reach a logically correct result without needing to understand the meaning of the words. That insight, centuries ago, it kind of laid the groundwork, the philosophical permission slip, if you will.
It's even think about building an intelligent device.
Right. And speaking of devices, or maybe before devices, the word computer.
Ah, yeah, that's a great point. Before 1936, a computer wasn't a machine.
It was a person, often a woman actually, someone who sat there doing calculations manually, or maybe with an early mechanical calculator.
Human cogs in the Industrial Revolution's machine.
You could put it that way. Then came Alan Turing, a real visionary.
At just 24, tackling this huge problem. Hilbert's and Scheiding's problem.
The decision problem, yeah. Basically asking, is there a foolproof, step-by-step method, an algorithm that can tell you if any mathematical statement is true or false?
A universal truth machine.
Sort of. And to explore this, he came up with the theoretical Turing machine, this imaginary device reading symbols on a tape, following rules.
But the really big leap was the next step.
Oh, absolutely. The universal Turing machine. That was the stroke of genius. A device that wasn't fixed but programmable.
It could read its own instructions, the software from the tape itself.
Exactly. That concept underpins, well, pretty much every computer, every smartphone, everything we use today.
And he didn't stop there. He also gave us the Turing test, the imitation game.
Right. The benchmark was simple. Deceptively so, perhaps. Can a machine fool an expert just through written conversation into thinking it's human?
If yes, it's considered intelligent, by that measure anyway.
And that test, they still run versions of it every year. There's the Loebner Prize.
But crucially, no bot has ever truly won it, have they? Fully convinced the judges.
No, not really. And that persistent failure, it wasn't just about not winning a prize. It pointed to something deeper. A flaw in the whole approach.
Which led us into the AI winter.
Exactly. There was so much early optimism. You had things like Eliza, the chatbot back in 1966. People thought we were on the cusp.
But then, stagnation, cycles of hype, then disappointment. Especially the 70s, late 80s. What was going wrong?
Well, fundamentally, they were trying to build intelligence from the top down, using symbolic logic.
Trying to write down all the rules for thinking.
Pretty much. Trying to mathematically model how we process language or recognize faces or understand intent. Coding endless specific rules for every situation.
Trying to replicate consciousness with code.
Yeah, trying to manufacture these mental, psychological qualities. And it kept hitting a wall. It was too complex, too brittle.
So if they couldn't figure out the human rule book, how did we get to where we are now? What was the big pivot?
It was, and this sounds strange, it was kind of a surrender. A giving up on that original quest.
Giving up?
Yeah. There's a great quote from AI professor Nello Cristiani. He said, "We didn't find the solution to intelligence. We gave up."
Wow. So they just stopped trying to build a thinking machine.
They stopped trying to build it by mimicking human thought processes directly. The turning point wasn't cracking the code of the brain. It was embracing a totally different approach. Machine learning. ML.
Okay, so the lesson was...
Yeah.
Stop chasing consciousness. Start feeding it data. Go bottom up instead of top down.
Exactly right. Forget the predefined logic rules. Let the computer learn by itself.
Wow.
By analyzing just incomprehensible amounts of data and spotting correlations, finding patterns, the system starts looking intelligent, but without necessarily understanding why in the human sense.
Right, these dumb geniuses are all around us now, like my spam filter.
Perfect example. It doesn't ponder the philosophical nature of phishing scams.
No deep insights there.
Nope. It just calculates probabilities, sees the words free money, urgent action, checks against millions of emails it's seen, and flags it as likely spam, statistically.
Or Amazon telling me what book to read next.
Same principle. It doesn't know you love epic fantasy. It just sees that people who bought book 1 and book 2 overwhelmingly bought book 3. Strong correlation. So it suggests book 3 to you.
It doesn't need to understand the plot, just the pattern.
Precisely. Utility through correlation.
But, okay, if it's all just correlation, finding patterns without understanding, doesn't that create problems? This led to a real split in the field, didn't it? A philosophical debate.
It absolutely did. Famously highlighted by the tension between the linguist Noam Chomsky and Google's Peter Norvig.
Chomsky representing the old guard, the symbolic logic approach.
Right. He was very critical. He argued these statistical methods, yeah, they give you predictions, sometimes very accurate ones, but they don't deliver actual understanding.
He had that analogy.
The bees. He said it was like scientists perfectly simulating a bee's waggle dance without ever asking why the bees dance or what information they're actually conveying. Prediction without explanation.
And Norvig's response. From the heart of Google, the data giant.
Norvig took the pragmatic view. He basically said, look, in the real world, simple models fed massive data sets often outperform complex, theoretically elegant models.
More data beats better algorithms sometimes.
Often, yes. His point was, nature's black box doesn't need to be defined by a simple model. If it works, if it's useful, maybe that's enough.
So it's really a debate about what knowledge is. Is it deep understanding or is it useful prediction?
Exactly. Utility versus comprehension. And that statistical, data-driven approach, whatever its philosophical status, it started delivering incredible results, especially in games.
Things that seemed impossible just years before.
The Go victory was just seismic. Go is vastly more complex than chess, many more possible moves.
And DeepMind's AlphaGo didn't just win against Lee Sedol, one of the world's best.
It crushed him, 4-1 in 2016. And crucially, it didn't play like a human. Its style was described as inhuman, creative. Sergey Brin called some of its moves beautiful, moves human masters hadn't conceived of.
That must have sent shockwaves, especially in places like South Korea where Go is huge.
Oh, it did. Reports talked about an AI phobia emerging. It felt like proof that machines, through data, could not just match but actually surpass human intuition, even creativity in complex strategy.
Okay, so Go is a game of perfect information. You see the whole board. What about games where you don't know everything? Like poker.
That was the next frontier. And Libratis from Carnegie Mellon tackled that. Heads up, no limit Texas Hold'em against top pros.
Where bluffing and incomplete information are key.
Exactly. The AI can't see the opponent's cards. It has to deal with uncertainty, bluffing, potential mistakes by the opponent. It needs robust strategies based on probability. And Libratis won.
And the value there isn't just winning at cards, is it?
Not at all. Those algorithms, that ability to strategize with incomplete information, that's directly applicable to real-world problems. Cybersecurity, negotiation, even military strategy, anywhere you don't have the full picture.
So the data approach conquered complex games. What about everyday tasks, like translation?
Another great example of the shift. Early AI translation was awful. They tried coding grammar rules.
Didn't work well.
Miserably. The breakthrough came when IBM got hold of bilingual documents from the Canadian Parliament, Hansard transcripts.
Like a Rosetta Stone.
Exactly. A huge, structured data set of parallel text. They fed it in, and the machine started learning correlations between English and French phrases. No grammar rules needed, just patterns.
And then Google took that idea and scaled it up massively.
Added the entire internet as their data set, more or less.
Yeah.
This allowed their algorithms to learn not just direct equivalence, but context, nuance, human preference.
Like knowing whether light means lumière or leisure in French.
Precisely. Based on the surrounding words, the context, something incredibly hard to code rules for, but learnable from millions of examples. It's correlation winning again.
Okay, so the triumph of correlation is clear. But this is where the friction really starts, isn't it? When these systems running on statistics and scale start interacting with the real world.
Yes, because the same thing that makes them powerful learning subtle correlations from vast data also makes them opaque.
The black box problem.
Right. The problem of explainability. Deep learning networks have layers upon layers of connections. They give you an answer, often a very accurate one, but tracing why it reached that specific conclusion, it can be practically impossible.
Like an oracle, it gives you the pronouncement, but not the reasoning.
Exactly. And that's a huge issue when things go wrong, which they do.
Especially with bias. When the system learns the wrong patterns because the data itself was biased.
And the examples are stark and often disturbing. The fault usually isn't some evil algorithm, it's the historical human biases baked into the training data.
Like Google's image recognition in 2015.
Tagging photos of black individuals as gorillas, a horrifying reflection of bias in the image datasets it learned from.
Or Microsoft's T chatbot.
Pulled from Twitter in less than a day back in 2016, it started spewing racist and aggressive language because that's what it learned from interacting with people online. It learned what it was fed.
And LaTanya Sweeney's research.
Finding that Google searches for names commonly given to black individuals were more likely to show ads related to arrest records. Again, reflecting patterns in the data, potentially amplifying societal biases.
These aren't just embarrassing glitches. The stakes get incredibly high when these systems make critical decisions.
Absolutely. We're already seeing AI used or proposed for use in medical diagnosis, loan applications, even setting prison sentences.
That automated sentencing tool.
The ProPublica investigation in Florida back in 2016 found that a widely used risk assessment tool was nearly twice as likely to falsely flag black defendants as future reoffenders compared to white defendants.
Chilling. The black box is making life-altering decisions and might be perpetuating historical injustice.
It's learning the bias present in historical arrest and conviction data and projecting it forward. The statistical model is just reflecting a biased reality.
Which forces us into really thorny ethical territory, like with self-driving cars. The trolley problem, but real.
Yeah. Who does the car choose to protect in an unavoidable accident? The sources mentioned Germany's attempt back in 2016 to create a legal framework for this.
What did they decide?
Their guidelines tried to establish priorities, things like protect human life over property damage, but also, crucially, the car cannot discriminate based on age, race, gender, or any other personal characteristic when making that impossible choice.
A clear statement that some values must override pure calculation.
Right. It highlights that the technology isn't the only hurdle anymore. We need ethical guardrails, political decisions, because, as Nick Bostrom said, no solution will be perfect. We have to decide what imperfections we can live with.
Listening to all this, what really stands out is that point you mentioned from Nello Christiani. These AI systems, they aren't HAL 9000 plotting against us.
No, not in the way sci-fi imagines. They're incredibly powerful statistical tools, pattern matchers, predictors, operating alongside us, often unseen, making decisions based on probability.
And the core challenge is grappling with the fact that we don't always know why they make the decisions they do. We trust the oracle, the mathematical black box.
That uncertainty, that reliance on something we can't fully dissect, that's the real practical anxiety of living in this AI age. The results can be amazing, but the responsibility for the inputs and managing the outputs, and that remains deeply human.
Which leads us to a final thought for you, our listeners, to maybe chew on. Way back in 1965, the mathematician I.J. Good, who actually worked with Turing, she suggested something profound.
What was that?
He said the first truly ultra-intelligent machine would be the last invention that man would ever need to make, implying it could invent everything else after that.
The singularity idea.
Right. So the question for you is, does today's machine learning, even though it's built on correlation and data, not human-like logic, does it genuinely put us on a path toward that kind of superintelligence? Or is that fear, that possibility, still just overblown science fiction for now?
Something to think about, definitely. As these systems get more capable.
Well, indeed. Thank you for joining us for this deep dive. We'll see you next time.